We have one question for frequently asked questions for section 3.5-day-3, and it involves Newton's law of cooling. We have a cup of coffee that's cooled from 92 degrees Celsius to 50 degrees Celsius after 12 minutes in a room at 22 degrees Celsius. How long will the cup take to cool to 30 degrees Celsius? So the second question isn't really the first thing that we need to do. I mean, this is the last piece of what we're interested in here. The first thing is, in order to figure out anything about this problem, we need to know what K is. And remember, K is that constant that has to do with what type of liquid is being cooled. So we need that information in order to keep going with this. So let's get started. The first thing we know is that the cup of coffee has already cooled to 50 degrees. So that's T of T. Now it did that, we're just going to follow this by the room temperature, which was 22, plus we have that null temperature up there, which means what did it start at? And it started at 92. And then again, we're going to use that room temperature. And then we need K, but we do know T. So we've got a time here of 12 minutes. So this will basically be a negative 12 K. So again, our job is to figure out what K is so that we can put it into the formula and use it for the second part. So I guess I'd go ahead and subtract 22 from both sides first. Get that done. And over here, 92 minus 22, we could certainly do that in the same step without losing too much there. And then we divide both sides by 70. Just trying to work to get that base of E by itself, isolate that. And this would work us down to 2/5, because 7 actually is not the biggest number that we can put in this. You know, you look at 28 and you look at 70 and you think 7 right away. But we can go bigger than that. We can go 14. And so now we have 2/5 equals E to the negative 12K. And then next up would be eliminate that base of E, and that would be by taking the natural logarithm of both sides. Because these are inverses, we'll have the natural log of 2/5 equals negative 12K, and then we would divide both sides by negative 12, but again waiting till the very end and then punching everything in, so we get the natural log of 2/5, then divide that by negative 12 following the order of operations, and K is 0.076357561. Now the reason that I'm keeping all the decimals at this point is because I don't want a rounding error. You know, we certainly, if we were supposed to find K, we could certainly do some rounding right here and use that 0.076, but we want to kind of hold on to the whole thing, since the second portion of this, which is what we are supposed to answer, we need that K for. That's the piece that we had to have to solve this. So now we want to know how long will it take it to get to be 30 degrees. So starting over with 30 degrees as the result, the room temperature is still going to be 22, and we still have 92 minus 22 in the parentheses. But now we do know what we have for K, and that would be E to the, and I'm going to have real trouble squishing that in here. So even though I wanted you to see the rest of this, I'm going to go down below here and do this work where there's more room. So 30 equals 22 plus 92 minus 22, E to the negative 0.076 T. Keeping in mind that I wrote down the whole thing so that we could get a closer, more accurate estimation of what's going to happen. So now we go ahead and do some math. So we can go ahead and subtract the 22 from both sides right away, and we already know what this is. We had to use it for the other one. And we see we're kind of in the same situation where we would divide both sides and we would have our 8/70ths, which again we would reduce, and that will reduce by 2 to 4/35, and then we'll have E to the negative 0.076 T. And once again, we would take the natural log of both sides. Here we're inverses. And finally, we would divide by the K value. And again, when I punched it in, I did use the extended version 0.076357561. And this came out to 28.407 minutes for it to cool. So that key value in this formula is important to have. In our Algebra 2 book, they would actually give us that information, but here we had to derive it, which is a good thing. You know, you don't always get that information, you don't always know what it is, but if you can make the math find it, then you'll have it for good.